Hello and welcome. In this video we are going to be solving 10 word problems. Alright, so without wasting much time, let us get right into it. The first question says 5 years ago a father was 3 times as old as his son. Now their combined ages amount to 110 years. Thus the present age of the father is. Alright, so let's represent the present age of the father with a variable and the present age of the son with a variable. So let's say let the present age of the father be x and let the present age of the son be y. Alright, so now let's go through the question again. 5 years ago a father was 3 times as old as his son. Now their combined ages amount to 110 years. So the very first thing you have to do is to get the present ages. Whenever you have a question like this, deal with the present first. After dealing with the present, then you deal with the past. Alright, so now to deal with the present, let's interpret this line. Interpreting this line, we have that their combined ages amount to 110 years, which means that the combined or the addition of the present age of the father and the present age of the son is 110 years. Alright, so that's interpreting the second line. Now it says 5 years ago. Alright, before we do that, let us get the present age of the father in terms of the age of the son. Alright, so we'll be able to navigate the question better. So the present age of the father is x. That means that the present age of the father will be equal to 110 minus y. Alright, so we can now say that presently age of the father equals 110 minus y and the age of the son equals y. Now to interpret this, 5 years ago a father was 3 times as old as his son. So what will be the age of the father 5 years ago? So 5 years ago, the age of the father presently is 110 minus y. So 5 years ago, the age of the father will be 110 minus y, the present age, minus 5. Alright? If I am 50 today, 5 years ago, I am 45. Right? 50 minus 5. So that's exactly what we did here. The present age minus 5. Because we're told 5 years ago, the father was 3 times as old as his son. So 5 years ago, the age of the son will be what? Y minus 5. Alright? The present age minus 5. Alright, so this will be equal to 110 minus 5 minus y. When you collect like terms, right? And this will be 105 minus y. So the age of the father 5 years ago was 105 minus y. Now to interpret this first line, okay, 5 years ago a father was 3 times as old as his son. So if this was the age of the father 5 years ago and this was the age of the son 5 years ago, that means that 105 minus y is equal to 3 into brackets y minus 5. Alright, so I'm just going to clear out all this so we can have more space. So we have that 5 years ago the father being 105 minus y years old was 3 times as old as his son. So now we can solve this. We're going to open the brackets, 3 times y, 3y, 3 times minus 5 minus 15, and now we're going to collect like terms. Let's take 105 to the other side and 3y to this side. So we're going to have minus y minus 3y equals minus 15 minus 105. So here we're going to have minus 4y equals minus 120. Now divide both sides by minus 4. You're going to have y to be equal to minus 120 over minus 4. And that will be equal to minus cancels minus, and will be equal to 30. So the age, recall that we said the present age of the sun is y, which means that this is the present age of the son. And we say that the present age of the father is 110 minus y. X is 110 minus y. So we're going to have 110 minus 30. So X, the present age of the father, is 80 years. And that is our final answer. So if you are asked to find the present age of the son, that is 30 years. And the present age of the father is 80 years. And that is all for question 1. Moving on to question 2. Question 2 says, find a 2-digit number such that 3 times the 10th digit is 2 less than twice the unit digit and twice the number is 20 greater than the number obtained by reversing the digits. Okay, alright, so as we did in number 1, let the 10th digit be equal to x and let the units digit be equal to y. Okay, so what is the 10th digit? What is the unit digit? If, for example, we have a number, say 57, alright, 5 represents the 10th digit, 7 represents the unit digits. Alright, so 5 means that we have 5 group of 10s. So we can write this as 5 is bracket 10 plus 7. And that's why we call it 57. 5 times 10, 50 plus 7, 57. So we have 5 groups of 10s. And 7 represent the unit, that is, we have 7 single units. Alright, so that is what 10th digit and unit digit mean. If we have a number, say 257, 2 represents the hundreds, 5 represent the tens, and 7 represents the units. So that's just by the way. Alright, so now let's get back to the question. So whenever you are given a question like this, always know that for every 2 digits, the original value is the 10th digit, right? Just like I explained with that example. Multiply by 10, that is x is representing the number of groups of 10s that we have. So x times 10 plus y. So the original value is always 10x plus y. And then when we reverse it, alright, so as I said, if we have 57, that will be 5 times 10 plus 7. And then when we reverse it, we're going to have 75. So 7 becomes the 10th digit. So we're going to have 7 times 10 plus 5. Alright, so here it's going to be 5y times 10 plus x. And that is 10y plus x. So this is the original value and this is the reversed value. Alright, so this should always be your first step. When you know this, you're one step ahead. You're 50% done. Alright, so let's move on with the question. So when you're solving word problems, always interpret the lines. Alright, you go line by line. Right, find a 2-digit number such that 3 times the 10th digit is 2 less than twice the unit digit. So let us interpret this. 3 times the 10th digit. 3 times the 10th digit will be 3x, because the 10 digits were representing it with x, is equal to 2 less than twice the unit digits. Alright, 2 less than twice. So let's say twice the unit digits, right? Minus 2. That's what it means. Twice the unit digit is 2y minus 2. Alright? So we can say that 3x minus 2y equals to minus 2. Let's take this as equation 1. Alright? And then the next line says twice the number is 20 greater than the number obtained by reversing the digits. So now we're going to interpret this line or these words. Okay, so twice the number, that means twice the original value, right? So twice the number, twice 10x plus y is 20 greater than the number obtained by reversing. So when we reverse and add 20, right, that's what that means. So is equal to 20 greater than the number obtained by reversing the digits. So reversing the digits, we have 10y plus x. 10y plus x. Alright. Okay, so I'm going to clear out everything now so we can have more space. Alright, so we've established that 3x minus 2y is equal to minus 2, and twice the number is 20 greater than the number obtained by reversing the digits. Okay, so now we can, solve this. 2 times 10x is 20x plus 2y equals to 20 plus 10y plus x. Collect like terms, 20x, bring x to this side, you're gonna have minus x, plus 2y, bring 10y to the other side, you're going to have minus 10y equals to, we'll be left with 20. So here you're gonna have 19x minus 8y equals to 20. And we have our equation 2. Now we're going to solve these two equations simultaneously. 3x minus 2y equals minus 2. 19x minus 8y equals 20. So when you solve this simultaneously by using any of your preferred methods, you're going to get a value of x as 4 and the value of y as 7. Therefore, the 2-digit number, 2-digit number is 47. Okay, alright, and this is our final answer. I've come to the end of question 2. Moving on to question 3. Alright, so question 3 says, father reduced the quantity of food bought for the family by 10% when he found that the cost of living had increased by 15%. Thus, the fractional increase in the family food bill is now question mark. So we're going to interpret line by line, right? So let us represent the original quantity of food. Let original quantity of food equals let's say P, right? Now, the quantity of food bought for the family was reduced by 10%. When you found that cost of living had increased by 15%, so let's say let the original cost of living, let the original cost of living equals say Q, right? So if the quantity of food bought was reduced by 10%, that means the quantity of food bought was reduced from 100% to 90%. So that means that the new cost of food, or the new quantity of food, the new quantity of food is now 90% of P, right? Because the quantity of food has been reduced by 10%. Right? And when you found out that the cost of living, you reduced it because you found out that the cost of living had increased by 15%. So if the original cost of living was Q and it was increased by 15%, that means that the new cost of living will be equal to 115% of Q, because if the original cost of living was 100% of Q, that 100%, that is the whole cost of living, was now increased by 15%, so it becomes 115% of Q. So the question says to find the fractional increase in the family food bill. So the original food bill we said the original cost of living was P and the original quantity of food was P and the original cost of living was Q. That means that the original food bill will be PQ. Now let me explain that. If you have 5 tubers of yam, that is the quantity, and each of the yam is sold at $100 each. That means that the bill will be 100 times 5, right? So that is multiplying each of the quantities by the cost to get the bill for the entirety. Alright, so that means that the original food bill would be PQ. And now that the quantity of food has been reduced by 10% and the cost of living has been increased by 15%, that means that the new food bill will be the new quantity of food, 90%. I'm going to write that as 90 over 100 of P. That's 90 over 100 P times the new cost of living, 105 over 100 of Q. So we could say 0 cancels 0, and then 9P times 115Q would give us 1035 PQ over 10 times 100 will give us 1000. Alright, let me clear this part. Now, having gotten the new food bill, we can now get the fractional increase. And fractional increase is equal to the new bill minus the original bill all over the original bill. Alright, now the new food bill is 1035 PQ all over 1000 minus the original food bill PQ all over the original food bill PQ. Okay, now I'm gonna clear this part. Okay, so when we subtract this we're going to have 7 over 200 PQ all over PQ. That is the same thing as 7 over 200 PQ times 1 over PQ. And our final answer is 7 over 200. And that is all for question 3. Feel free to drop your questions or your confusions in the comment section. Now we move to question 4. Question 4 says 3 boys shared some oranges. The first received 1 over 3 of the oranges, the second received 2 over 3 of the remainder. If the third boy received the remaining 12 oranges, how many oranges did they share? Alright, now let's say let the total number of oranges equal x. Okay, now the first received 1 over 3 of the oranges. So first boy received 1 over 3 of the oranges, because we have x, total number of oranges. So if the first boy has received 1 over 3 of x, that is 1/3 of the oranges, that means that the remainder is equal to x minus 1/3 of x. So it's just like saying I have, say, 10 biros and I removed 1/3 of the 10 biros from the 10 biros. So I'm subtracting what I have removed from my original value to have my remainder, to have what I have left. What is left is the remainder. Alright, so when I subtract this, you could use LCM. So you could say LCM is 3x minus x, and this would give you 2x over 3. So I am left with 2x over 3 as my remainder after the first boy has gotten 1/3 of the oranges. Alright, now the second boy now received 2 over 3 of the remainder. Now of means multiplication, so the second boy receives 2 over 3 of the remainder, which is 2x over 3. So the second boy receives 4x over 9. And finally the third boy receives 12 oranges. That is what is left, the remaining 12 oranges. Okay, so we're going to sum up what the first boy received, what the second boy received, and what the third boy received to get the total number of oranges. So first boy received 1 over 3x, 1/3 of the oranges. Second boy received 4x over 9, 4/9 of the oranges. And the third boy received the remaining 12 oranges, and that is equal to the total number of oranges. Alright, now we can simplify this, and we could say 1/3 of x plus 4x over 9 minus x equals to minus 12. Now when we simplify this, we're going to get minus 2x over 9 equals to minus 12. And minus cancels out minus. Then we can cross multiply to have 2x equals 9 times 12. And 2x equals 108. X equals 108 over 2. And our final answer is 54. Therefore, we have 54 oranges shared. And this is the correct answer to question 4. Now we move on to question 5. Question 5 says 4 boys and 10 girls can cut a field in 5 hours. If the boys work at 5/4 the rate at which the girls work, how many boys will be needed to cut the field in 3 hours? Alright, so to interpret the question, 4 boys and 10 girls can cut a field in 5 hours. If the boys work at a pace, or if the boys work at 5/4 the rate of which the girls work, that means that we have a ratio of 5:4, meaning that 5 girls will do the same work as 4 boys. 4 boys will do the same work as 5 girls. They will work at the same rate, at the same pace. Alright? And then we can now say that 10 girls will do the work of 8 boys. Okay? Are you seeing the pattern? 20 girls will do the work of 16 boys. Alright, so that is how it works. So going back to the question, we have 4 boys and 10 girls cutting a field in 5 hours. So if we replace the number of girls with boys, if we substitute these girls for boys, we know that 10 girls and 8 boys will work at the same rate. Alright, so we could substitute these 10 girls with 8 boys. Okay, so from that we can conclude that 12 boys will work in 5 hours. Okay, 4 boys and 8 boys, making 12 boys, can cut the field in 5 hours. And then we can now easily answer the last part of the question: how many boys will be needed to cut the field in 3 hours? Alright, so if 12 boys will work in 5 hours, how many boys will work in 3 hours? So we're going to use a very simple formula that says time 1 times the number of men is equal to time 2 times the number of men. Alright, so time 1, 5 in 5 hours, 12 boys will work. So we have 5 times 12. In 3 hours, we're looking for how many boys? X. Okay, so from here we can easily say that 5 times 12 is 60, equals to 3x, then divide both sides by 3, x equals to 60 over 3, and that is equal to 20 boys. So 20 boys will work in 3 hours. And to be sure that you are actually correct, thinking about it, if 12 boys will cut a field in 5 hours, definitely you need more boys to cut the field in lesser time. Alright, so you are actually correct to have a larger number. So this brings us to the end of question 5, and stick around for question 6. Question 6 says a basket contains green, black, and blue balls in the ratio 5 to 2 to 1. If there are 10 blue balls, find the corresponding new ratio when 10 green and 10 black balls are removed from the basket. Alright, so we have the ratio 5 to 2 to 1, representing the green to the black to the blue. Alright, so it says if there are 10 blue balls, so since it is in the ratio 5 to 2 to 1, if we have 10 blue balls, we're going to have 20 black balls, and we're going to have 50 green balls. Alright, so find the corresponding new ratio when 10 green and 10 black balls are removed. So the new ratio will be, when we remove 10 green from this 50 green, we're going to be left with 40 green balls. When we remove 10 black from this 20 black, we're going to be left with 10 black balls, and we still have our 10 blue balls. Therefore, our new ratio is 4:1:1, and that is the answer to the question. Moving on to question 7. Question 7 says 30 boys and X girls sat for a test. The mean of the boys' scores and that of the girls were respectively 6 and 8. Find X if the total score was 468. Alright, so you can pause the video and attempt the question. Okay, so we have 30 boys and we have X girls. So you say number of boys equals 30 and number of girls equals X. The mean score, so the mean of the boys, mean score of boys equals 6, and that of the girls, mean score of girls equals 8. So we know that mean is equal to the sum over the total number. So for the boys, we know we have the mean score and we have the total number, so we can get the sum. So let's say the mean score for the boys, let's denote it as MB. So MB will be the sum of the scores over the total number of boys, which is 30. Alright, okay, let me write it as N. So MB is 6 equals to the sum over 30. So the sum for the boys, sum of scores for the boys will be equal to 6 times 30, which is 180. Okay, we'll do the same for the girls. Let's write that as MG. That's sum over N. Alright? Okay, let me just cancel that out. So the sum for the girls will be the number of girls, which is X, multiplied by MG, the mean score of girls, which is 8. Okay, so this will be 8x when you cross multiply. Okay, so if the total score was 468, so the total score will be the total sum for the boys plus that of the girls. So 180 plus 8x equals to 468. So from here we can get our value of x. Take 180 to the other side. 468 minus 180. We're going to have 8x equals to, when you subtract, let us subtract 468 minus 180. We're going to have 288. Then x will be equal to 288 over 8. And when we divide that, we're going to get our answer as 36. Therefore, we have 36 number of girls that sat for the test. And that is it for question 7. Moving on to question 8. Alright, so question 8 says the ages of Tosan and Isa differ by 6. And the product of their ages is 187. Write their ages in the form x, y, where x is greater than y. Alright, so let the age of Tosan equal to x, and let the age of Isa will equal to y. So if their ages differ by 6, we could say that x minus y equals to 6 because x is greater than y. That's why x is coming first. You know, age is always a positive value. Alright, so x minus y will be equal to 6. And it also says that the product of their ages is 187, which means that xy equals 187. So we're going to solve this equation and this equation simultaneously. We have equation 1 and we have equation 2. Alright, so the best method for us to use here is the substitution method. So let's say x from equation 2, x equals to 187 over y. We can come to equation 1 and substitute x in equation 1. We're going to have 187 over y minus y equal to 6. Okay, so we have y as a fraction. We can multiply through by y. So we can say y times 187 over y minus y times y equals to y times 6. Okay, so we can deal with the fraction. We'll be left with 187 minus y squared equals to 6y. Alright, so writing this in form of a quadratic equation, take minus y squared to the other side. You have y squared and leave 6y, positive 6y. Take 187 to the other side, you're going to have minus 187 and you're left with 0 at the other side. Okay, so now we're going to solve this quadratic equation. Okay, so 17 minus 11 will give us 6, and 17 times minus 11 will give us minus 187. So we're going to have y squared plus 17y minus 11y minus 187 equals to 0. Here, factor out y, you're left with y plus 17 minus factor out 11, you're left with y plus 17. Minus 11 times 17 will give us minus 187 equals to 0. So we're going to have y minus 11, y plus 17 equals to 0. So we have y to be equal to 11 or y to be equal to minus 17. So definitely we know that this cannot be the answer because this is a negative value and age is not negative. So we're going to pick this as our value for y. Okay, so since x is greater than y, to get x we can just use any of the equations. So let us use this equation. No, let's use equation 1. Okay, so from equation 1, x minus y equals to 6. X equals to 6 plus y, and x equals to 6 plus 11. Okay, so let me just clear out this part. So we could say x equals to 17. Alright, 6 plus 11, 17. Therefore, the age of Tosan is 17 and the age of Isa is 11. So writing it in this form, we're going to have it as 17, 11. And this is our answer to the question. Moving on to question 9. Alright, question 9 says, on each market day, Mrs. Bassey walks to the market from her home at a steady speed. This journey normally takes her 2 hours to complete. She finds, however, that by increasing her usual speed by 1 km per hour, she can save 20 minutes. Find her usual speed in kilometer per hour. Alright, so when we have a question like this, first thing we do is write a formula for speed. We know that speed is equal to distance over time taken. Alright, so let's interpret the question line by line. So it says she walks at a steady speed from the market to her home, or from her home to the market. So let's say let our usual speed be equal to v. Okay, so this journey normally takes 2 hours to complete, so that is our usual time taken. Usual time taken is 2 hours. Okay, she finds, however, that by increasing our usual speed, okay, before that, let's say that we have the speed and we have the time taken, so we can have the distance. Okay, so distance in this instance is equal to speed times time taken, which is v times 2, which is 2v. Okay, now she finds that by increasing our usual speed by 1 kilometer per hour, so new speed now is equal to the usual speed plus 1. Alright, so v plus 1, that's the new speed. And the new time taken, the new time, says by increasing her speed she can save 20 minutes. Okay, so if she takes 2 hours normally and she wants to save 20 minutes, okay, that means that when you subtract 20 minutes from 2 hours, okay, when you subtract 20 minutes from 2 hours, you're going to be left with 1 hour and 40 minutes, right? Okay, so when you subtract 20 minutes from 2 hours, which is our usual time, you're going to be left with 1 hour 40 minutes. Alright, so let's convert this 40 minutes to hours. We're going to have 1 hour 40 over 60 hours. Okay, so let me write it up here. New time is equal to 1 hour, let's just say 0 cancels 0, and we're going to be left with 2 over 3. 2 over 3. Okay, so that is the new time. Alright, so still having in mind that distance is speed times time taken, the new distance will be the new time multiplied by the new speed. Alright, so distance is new speed v plus 1 multiplied by 1 on number 2 over 3. We can write that as 5 over 3, changing it from mixed fraction to proper fraction. Alright, so take note of something. The distance from our home to the market will remain the same even if she increases the speed. Okay, so this distance and this distance will be the same. Alright, and that is how we're going to get the usual speed, which is v, by equating this distance and this distance. Alright, so let me clear out this part. So 2v is equal to 5 over 3 into v plus 1. Cross multiply, you're going to have 6v equals to 5v plus 5 times 1, 5. Take v to the other side, you're going to have 6v minus 5v equals 5, and v equals 5. Now let me just do that bit. So we can conclude that our usual speed is 5 kilometers per hour. And that brings us to the end of question 9. Moving on to the final question. The final question is a bonus question for you to solve and drop your answer in the comment section. And we have come to the end of this video. Don't forget to like, don't forget to share, and don't forget to subscribe. Thank you for watching, and goodbye.